Hello everyone, welcome to 3D Studies. This side Adya, and after watching thumbnail, you all are get ready for your class 12 physics chapter number 1, electrostatic, well known as your electric field and charges. So, as we all know, the chapter name, that is your electrostatic. What does this mean with, right? So let me tell you. If we wanted to break this particular article, we came across electro. So I wanted from you to tell me, what does electro mean? That's great if you know it. That means your charge. Cleared it out, everyone? Now if I ask you what is a static, now this word static is very formal from class, I would say science of 9th. Static word is oftenly used, and that is your rest. What is that? So in this chapter, we will focus majorly on the charges which are at rest. Clear it out what we are going to have in this chapter, and wait. Only not about the charges, but everything about that. What does mean? Due to charge, what happened, and what comes with, I would say, what is related, or what are the term that is related to charge. And yes, our chapter not only end with the charges, also there is the topic field. So we will be focusing well as on charges as well as on your field. So if you all are excited, please hit the like button and do share the video with your friends. So without any kind of ado, let's move ahead and understand the chapter electrostatic. As this chapter begins with your charges, which is at rest, you would formally ask me, ma'am, what do you mean by charge? So let's discuss it, everyone. See, what is your charge mean? Now, please focus on here. Different people from you, different teachers, and different experience they would be gaining from the books or the sources, totally going to have the different kind of definition for your charge, right? Charge is not only a small quantity, it's a huge kind of water. So we will be understanding today what is charge. If you know the definition, do write in the comment below. But here, let us begin it, that what does charge mean? Why this term charge is only there? कोई और term यहाँ क्यों नहीं आया? Right? See, basically the first thing is, चार्ज क्या है? चार्ज एक एवरीवन, चार्ज एक तरह की I would say property है. Clear it out? What is charge? Charge is a type of property. अब you would say भाई property क्या होती है? You don't know. So let me clear it. देखो होता क्या है, जैसे कि we all know that there is light, right? And if I ask you a formal question that what is a light, or I would say what is the property of light, you would say light is made up of your energy. And the properties of light is the sum of your energies. Similar goes for charge. Charge is a type of property by virtue of which any kind of object could be x, y, z, any, or particle. So I want you to repeat it again while writing the definition for your charge. Everybody, what is charge? What is charge? Charge, it is the property by virtue of which any object, everyone please focus on the board, any object, or I would say the particle. Now from here what I'm going to write it, your definitions begin, right? So any object or particle, any object or particle, right? Experience or produce so everybody please focus this again. What is charge? It is a property, as I told you, by virtue of which any object or particle experiences or produces your electric and magnetic force. I hope so you get some kind of idea what is I'm going to talk to you about what is charge, right? See everyone, we all know what is charge, right? होता क्या है, there are some kind of, I would say, many neutral bodies are there, right? And on that neutral body, I would say this is a neutral body. Neutral body. And take an example, assume it. If I bring any kind of, I would say, positive body, right? Mark my point. Positive body towards this neutral kind of body, anything will happen. And yes, if you are able to think upon that. Neutral body, and I wanted to repeat it, here the neutral body is your conductor. Right? If this neutral body is your conductor, it will definitely have the free electrons. And if it have your free electrons, definitely your negative charges, which is well known as your electrons, gonna attract it towards the positive charge. What will happen? In the neutral body, which is your, I would say, conductor, let us example, it's a conductor, what will happen? Negative charge will feel some kind of attraction towards the positive charge, and similar goes with the positive charge. What would happen? It will feel some kind of your repulsion. So as I just told you, any object or particle which experiences or produces electric and magnetic force is called your charge. Hopefully clear to everyone? Right? I hope so clear. If you wanted to write the definition, you can do write it. And now let's begin it. You would say, कि अभी तो मुझे कुछ समझ नहीं आया. I understand what is charge, what you wanted to say, but what more can you tell about that? For understanding more, we will be having our feet towards the properties for the same. So let's discuss it. Now, everyone, let's have a look. If I want from you to tell me what is a force, whether it's a scalar quantity or vector quantity, you will follow it. You will definitely gonna jump at that. Yes, it's a vector quantity. We well known as, right? But in this chapter, we are focusing upon the charges. So the property number 1 we came across is your charges. Before going ahead, I wanted from you to tell me whether it's a scalar or vector. Think it. Push your mind towards the diagram we just came across, that whether your charges are, I would say, scalar or vector. If you think it, that's great, and the reflection could be towards your scalar for sure. If you wanted to know why, let's discuss it, everybody. See, charges, I just told you and you reflected that they are your scalar. What are they? A scalar. Now you would say how we want the result. So everybody, see, as I just told you, there was a neutral body which is I took up as a conductor, and after bringing any kind of positive body, it could be negative too, then positive charges will be attracted towards. Let's take one case, and you would be, your homework is to do the, I would say, the other case by your own, and the homework is not about your writing skills, it's of your mind, right? Think it about that. Well, the example which we were taking today was your positive charge, and we were taking any kind of conductor, which is our hair is a neutral body, right? What happened? It's definitely gonna have some kind of free electrons. What happened? It on carrying of your positive charge, it will definitely gonna have your negative attraction towards positive, and positive will feel some kind of attraction or repulsion. Clear it out? If I put this body over here, what would happen? Negative charge will here gonna come, and positive will feel some kind of repulsion. What happened? Does, my question is again, does charge is dependent on your direction? Charge को किसी भी तरह के direction की need होती है, everybody. There is any kind of need of your charge, need of your direction for your charge? If your answer is no, that's great. You can clearly see it. Charge को किसी तरह की direction की need नहीं होती. Everybody, what happened is charge is free, right? Charge is free, and one more point we can conclude from here, that is, if there is a body which has some kind of mass, for sure, if there is any matter or body, it's for sure going to have the mass. And here's the body which is also having the mass, and if I get it into this particular body, any kind of charge, it could be positive or negative. Positive or negative, right? And here, now everybody, okay, sorry for that. Now everybody, focus it. What I wanted to say to you, what is, There are three cases. What are the three cases? There is a body with mass m. There is a body with mass m with a positive or negative charge. Okay, everybody? And there I wrote as positive or negative. The three cases I took up are here. Now I want you to know from you what this particular figure means. You will for sure gonna have that what you were asking. It's the matter or any kind of body having the mass m and number that. I said that's great. If I ask you what is this thing, you would say the body carrying some kind of mass and for sure it will having some kind of negative or positive charge according to what charges you formally gonna get on that particular object or particle. Clear it out? Now if I ask you what is this, what you would say? This is a positive sign, this is a negative sign, nothing more than that. Right? Now everybody, if I ask you which is stable, does this particular particle with the mass m is stable or not? You would say yes. There are many particles, many objects in the world which stays without having the charge. Clear it out everybody? What I wanted to say here? Now everybody put on your eye on the statement. I'm going to write it. That is mass can exist without what I spoken it, I'm gonna write it over here that mass can exist without charge. But your charge, you can clearly see it. The charge which have your mass is stable. Is clearly seen by us that this particular figure, or I would say the diagram, is appropriate or here. But if I ask you without mass any kind of charge is not stable. Clear it out everybody? What I wanted to write it, mass can exist without charge, but charge can not exist without mass. Everyone, mass can exist without charge. Charge cannot exist, I would say can't exist without mass. Clear it out? ये हम लोग properties discuss कर रहे हैं everybody, right? And from here we can clearly see that mass is your variant and charge is your invariant. Now you'd say, what does this mean? Everybody, your mass is variant and charge is invariant. Why? Because mass is independent of charge and charge is dependent of your mass. Clear the properties? And that particular property is not oftenly to tell you that what is the SI unit and what are the units for your charges. Well, you can clearly see from your book. Clear it out? Okay? I hope so you understand the properties for your charge in somewhat detail. Now, we are going to have the types of charges. You would say, wait. I know it's positive charge and it's negative charge. Just you wait and watch it, everybody. If you wanted to write, you can write it. And the point you can oftenly, if in exam, it could not comment, but oftenly, it have the question like assertion or reason based that whether the assertion could be mass is dependent of your charge, and the second statement could be mass is independent of charge. What would you say? Which assertion is wrong, which is true, which is wrong, right? So this kind of question can come, or the question can come, mass is variant or invariant, right? So think upon which type of question can occur, right? What are the format can come according to your question regarding coming in your board, right? I hope you understand. Now, everybody, we are going to have discussion on the types of charges. That is your types of charge. Types of charge. We all know, you just told me there is a positive charge and negative charge. But well, I'll be classifying it as similar to you, but see, what I'm going to write, deficiency of electron and so we will not say the charges are positive or negative. We will at that place gonna use it wherever we'll find the deficiency of your electron. And wherever there will be some kind of excess of electrons, that kind are known as your types of charges. Clear it out, everybody? And in eco, we just name it for our formal talking that what is the deficiency of electron species mean. That is well known as your positive charges, and this your negative charges, which have the excess of electron as a negative charge, and which have your deficiency of electrons have your is called your positive charge. Clear it out? Now everybody, put an heading which comes up with one more property is there before gonna discuss the another kind of, I would say, the part through which there I would say some in our books also the property comes like charge is quantized. Charge is quantized, right? Now everybody focus it on what I wanted to say to you, right? Now charge is quantized. After reading it, what the first letter comes to your mind? Quanta is something which we have listened a lot of time, and there is some kind of, I would say, topics or books are there, quantum physics, but okay, partner, like that of scenarios come in your mind, right? So we came across quanta word, right? And you all know what the mean of your quanta is. What is the mean of your quanta is? We all know this is mean your packet. राइट डजंट मैटर इट किस चीज का डिपेंडेंसी है, किस चीज की हम लोग बात कर रहे हैं, राइट? व्हाट इज क्वांटा इज meant to be your packet, right? Quanta is meant to be your packet, right? अब what is your charge if quantized mean? Mean is that charge neither be created nor destroyed. It just transformed from one place to another. What does mean it with? What is the mean here? Charge is quantized. That we cannot do like that. Like that, we can have the example. If I have a chocolate and I have a small brother or sister, so he or she wants from me to have the chocolate half, so I will just crack the chocolate. I'm gonna give half to them and one half to with myself, right? It's not gonna half or here. Charge is something which could not be broken. You say, why? I didn't understand it. Because what happened is, charge always exists as in the form of Q is equals to plus minus NE. You would say, ये तो आया नहीं समझ में, अब ये कहाँ से आ गया, right? Everything is related to one thing. Charge is quantized mean charge would neither be gonna have in the format of half, right? Charge कभी भी टुकड़ों में नहीं मिलेगा. It will definitely gonna have in the packet. Like it means fulfilled, right? Charge can only be you can say transformed. राइट ट्रांसफर हो सकता है या फिर चार्ज को लिया जा सकता है, बट चार्ज could not be other than quantized. Clear it out? And that is why to prove my statement what I spoken to you everybody, I just wrote the definition, or I would say the formula, which is Q is equals to plus minus NE. You would ask me, what does this mean? This means charge on the body always exists on the form of Q is equals to plus minus NE. And during the question I'll be discussing after a while, you would be coming across that why only charge exists in the form of Q is equals to NA, not in the form of other than quanta. Clear it out, everybody? See, what I wanted to prove and how I'm able to prove my statement well in front of you. That's gonna be so similar. Let's take an example. Example number 1. What happened is, there is a kind of a body. Any body, right? Any object, any particle. You know, body, particle, or I would say anything is figured that's reposed thing, right? Here is the body. If I say you similar, bring out 5, I would say 5, not 7 electrons out of it. I wanted to remove 7 electrons from it. I wanted to take, this is the particle having some kind of, if it is, the particle is neutral, therefore it is going to have the positive or negative charges, because you know that's the particle we'll be talking about whenever we talk about taking or I would say providing some kind of electrons, or I would say taking out some kind of electrons, that particle or object gonna have in the form of conductor, right? What happened in this particular particle I wanted to refer is, I wanted from this particle to please give me 7 electrons. What would happen is, this particle will have a positive charge on it. You would say how? अब यहाँ पे देखो, you would be saying to me that the types of charges are your positive charges and negative charges. You would be able to understand why that particular thing happened. Not at all, everybody. What happened is, What is a negative shine source? What is a negative shine source? This means on this particle, I wanted to remove 7 electrons. So what happened? This particular particle have the deficiency of your electron, that is number 4. This particular particle have the deficiency of 7 electrons, and the other particle which is having the particular 7 electrons will have the excess of electrons. Clear it out? That's the another case of your science, or I would say chemistry. But here's why what I wanted to say, the symbol for your science, right? Take another example. This would be example number 1. Now let's take an hypothetical example because it doesn't exist at all. But you can have a question that why not? I wanted to know the reason. So for that, please everybody look at. There is a particle having the, I would say, nothing having it, a neutral body, and I wanted from this to remove what 8.6 electrons. I wanted to remove 8.6 electrons. You would say that not a problem. I'm just gonna have the positive charge on it. I'm just gonna have the positive charge on it with a symbol, or I would say the number, how much the electron have been dropped out. Right? What happened? 8.6 electron had been carried out of that particle, and 8.6 electron charge is gonna have on that particular particle. Clear it out? Now, I wanted from you all to think upon that, whether this statement or this statement is wrong or true. Or both are true, or one is wrong, one is independent, what is happening over here? I wanted from you to think it. Okay, if you're reflecting in a correct path, you'd be great. And I'm going to tell you what's the reason behind your reflection. This statement is for sure correct. I just told you, charge can be attracted, or I would say charge can be removed, or I would say gained. But the reason behind that, charge must be an integer. And in this case, what is happening? Charge is removed on the basis of your decimal. And the formula which I just told you, Q is equals to plus minus NE. On this, what if I put the value of E, which is your 1.6 into 10 to the power minus 19 coulomb, N number of electrons, Q, okay? So N is, and if I wanted to know the number, right, which is gonna come in the form of integer or not, if here you look, put the value of N, N is equals to Q by E. Whatever the charge is there and the value of electron put over here, similar goes with here, Q by E. And do write in the comment below if you want, or you can think it on your own, that whether this particular N is your fully filled integer or this N. Definitely, the answer gonna come this. N over here is a whole number, integer. Here what happened is, whole number while speaking it is a part of integer, right? And here, it is not gonna come in the form of your integer. Clear it out, everyone? After solving, you will get it, right? Taking any kind of example by koi bhi point ho, we'll be carrying out ki that's gonna be wrong. So that's not a, I would say the good way to think upon that. Pehle n ki value nikalo, then think upon that whether this case is possible or not. Clear it out, everybody? I hope so you got it, right? Now let's move ahead and okay, now let's discuss one of the most important topic, which is how to develop a charge, right? So what's the topic over here? Ways or methods of charging. What is the topic? Ways or methods of your charging. Clear it out? So, in this chapter, we will be majorly focused upon the two types of ways, that is your induction, well known as your induction, and other is your conduction. So what are the two ways we're going to have focus after a while? That is your induction and conduction in some more detail. You would say only two ways are there? No. There are many ways for, charging the charge, or I would say the particular ways we'll be understanding for the charging. So there are many further ways. You'd say how? We have took a very common, I would say, the activities we came across. We have a comb. We just press the comb on our hair, right, for a while, for charging it, right? We feel it's charging it, and for resorting it to the that it's true or wrong, we came across some kind of piece of paper on a desk, and what happened after rubbing it on our hair, we just came across to the particles or the paper we just kept on the table and wanted to stuck that particular papers on the comb, and what happened to magic? Definitely that piece of papers is stuck to the comb, and you can clearly see that comb or a ruler also, it happens with the ruler too. What happened, it just is stuck to the comb. So what does this mean? This way of charging is known as your frictional charging or electricity. What mean it? We just did a friction type of thing, and what happened is that particular object charge itself and shows that particular activity. There are many further ways. The emission is there, and I could not refer it to the original part, but there is, yes, photoelectric effect. We often have learned about in class 11th chemistry that what is your photoelectric effect? That E is equals to phi threshold energy plus kinetic energy, right? So in that, what happened? We have a metal surface, and the light emitted on the metal surface throws back the electron which is emitted towards from that particular metal surface. So what happened? That shows some kind of, I would say, photoelectric effect. That's also the way of charging, right? But if we will not focus on that, we're not studying chemistry or here, right? So what we will focus it, we'll focus basically on our induction and conduction. Isme we will see some kind of small things in tomorrow, but because our major focus will be on your Coulomb law and moreover on whatever the coming in this particular chapter gonna be had, right? So without further ado, let's move it and understand what is the induction had called it, right? Everybody see it, induction we have just took it, and induction हमने already पढ़ लिया है, but the thing it only to tell me to you that what happened it, right? So again, induction happened in two ways. That is, here is your conduction happened by two ways. That is your conductor or insulator. I'm sorry for the ways I just took it. I just would mention it. I'm not able to recognize it. The ways were induction and conduction. I wrote that only. If yes, that's great. And if not, correct that, right? What are the ways? Induction and conduction. And in the conduction, there are two ways. Again, the two parts, which is your conductor or your insulator. Oh, clear it out, everybody? Okay. Now, what does your conductor mean? As I just told you, conductor gonna have the free electron. And before moving ahead for understanding both of the topic, let me clear one thing to you, that induction, what mean? Induction means we are going to charge the particle without letting the particle knows that yes, you're going to charge it by positive or negative charge. You would say, this magic you're going to do it. For sure, yes. What happened is we will be charging the particle on the behalf that the particle will not feel any kind of, I would say, the thing that the particle is touched from something and had came across to the charges. No, without touching the particle, we came across for getting the charge on any kind of body or particle. Clear it out, everybody? That's great. For the example, for your conductor, we often know conductors must have your free electrons, and if you have any kind of particle, right, which is a neutral, and if I came across any kind of, I would say, this is a ruler or any kind of particle having the negative charge on it, what happened? This particular neutral body will have free electrons, and what happened? Positive electrons gonna attract toward the negative charge, and yes, there are two neutral body for the example of your conductor. I'm gonna take it, and again here is a body which will feel the repulsion due to the negative charge over there on the other sheet. What happened? Pehले दोनों bodies were kind of neutral. What happened on bringing the negative charge towards them, not letting the charges that yes, we have touched to you, right? Happened? We just came across to the negative charge towards that particular body. Then what happened? Due to that, if I just detach both of the body, we came across a negative charge on it and a positive charge on it. And you can clearly see it. यहाँ पे वो लोग neutral थे और यहाँ पे उन पे charge develop हो गया. And without having any kind of thing, just having the, I would say, negative charge towards that, we were able to do such activity, right? What does mean? What does mean? Conductor means rearrangement of the charges. Charges का rearrangement करना on the basis of without touching the particular objects or particles. Clear it out, everybody? Now you will ask me, so what is the your insulator mean? Let's discuss it. Okay, insulator have the similar case too. It does not have free electrons, but we will be having some kind of activity for showing the insulator to be charged. Well, in the induction, major focus of ours should be on conductor and not on insulator. And also, there keeps a term that is your dipole moment. Dipole moment. For understanding dipole moment, I'm not jumping it towards the topic. I'm not changing the topic. What happened at everybody? What happened at? Don't write it. From here only look it. There is any kind of surrounding. Clear it out. There is any kind of surrounding or the place where I have a lot of, okay, where I have a lot of, I would say the positive and negative charges. Positive and negative. 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 Right? They are just alag, right? They are just roaming on the surrounding, right? Or an particular closed surface, right? Now what happened if I ask you that I bring a particle having the positive charge on it, what would happen? You will clearly see a magic. What would over happen? As a result, you will be came across the diagram like this. Okay, it's not the circle. Just a second, everybody. And so on. What happened due to here is a positive charge, negative charges will feel some kind of attraction towards the positive charge. And due to these particular, I would say, particle have positive as well as your negative charges, what happened negative feels attraction, so the positive will feel for sure your repulsion. And if I wanted from you to know, either the case kya hone wala hai, everyone. Yes, if it is positive, the negative charges of your other particle will feel some kind of attraction towards the, I would say, first particle, and similar goes with the positive charge, it will feel some kind of repulsion. And dash, all the surface particle will arrange in the format. Clear it out? Now what happened? Learning of your, I would say, two particles and the charges, another thing. But when this happened on an, I would say, surface or any kind of grouped manner, it's called your dipole moment. Dipole moment. Write the definition on your behalf. What happened? When this particular things happen on a group manner, it tells you that this particular movement of, I would say, the electrons from one place to another on the behalf, कि किस electron को किस से repulsion feel हो रहा है और किस से attraction feel हो रहा है, and arranging them on the format कि किस को किस से arranged होना है, that knows as your dipole moment. As simple as that. Don't go on definition. It's so simple, right? So major focus हमारा induction के अंदर conductor पे रहेगा. Everybody clear it out. I hope so, right? If you wanted to write it, लिखने को कुछ था नहीं, समझना ही था. Now here, let's discuss it. What is the mean of your conduction over here? Now everyone again focus it very well, because insulator was something कि भाई केवल conductor पे ही हमें we're gonna have the eyes on, but here is your topic is conduction. What is the topic? Conduction. Now for understanding conduction, let me draw the diagram again. We have two bodies, or I would say two conductors on the behalf that they are connected through any medium. Okay, we are taking two kind of conductor, which is some kind of attached towards them, for I would say attached together for I would say here's what is, I'm going to take two bodies, which is your conductor, and for their conductivity we are just having the I would say the wire between them. And what happened over here, everybody, what happened, we want the flow of charge towards this particular medium, right? Now here says, if this, I would say you, this is a neutral body and this is Q charge with a Q charge. And I want the flow of charge towards your neutral body. What would happen in everyone? After when I attach to this wire which is outside to this particular neutral body, what would happen is we will see the attachment over here. Clear it out, everybody. And what happened is charge will start flowing, and definitely it's gonna distribute it with Q by 2 and Q by 2. Yes, whatever you are thinking, that's great and write it. But again, I wanted from you to tell me a statement I wanted to write over here, that how much time will charge flow. I wanted from you to think or reflect how much time will it take that particular, I would say, flow, right? Transfer of charges कब तक होगा, कितना टाइम लगेगा दोनों चार्जेस को बराबर होने में, ये तो बोला जाएगा everybody. I wanted from you to know दोनों चार्जेस को बराबर होने में और how much time it would take to come at rest कि किसी भी तरह का flow ना हो. What is your answer, everybody? What I spoken that similar kind? If your answer is कि मैम जब तक दोनों बॉडीज में चार्ज बराबर नहीं हो जाता तब तक फ्लो करेगा. At the end, जब चार्ज दोनों में बराबर हो गया, we will came across that both the particle will come across the rest. And the statement which you spoken was charge will come at rest. Charge will come at rest when it will have the same charge, same quantity of charge on both the side, and the statement is your wrong. You would say, what does this mean with? You have to confuse me a lot. Wait, let me tell you. I also keep this particular diagram in your mind, and if you wanted to write it, you can write it again. And what happened? Let me give you a short idea what I wanted to say to you. Everyone, focus it. होता क्या है? I wanted from you to tell me that whether, like, let's take an example. This is your, I would say, just a second. Okay. There are two, I would say, the mugs are there, or I would say the glass is there. Two glasses with some kind of length, right? Differs it कि ये width है, ये ज़्यादा breadth का है, वो कम breadth का है, right? Now here's what happened. I wanted from you to tell me. I'm gonna fill the water over here. I'm gonna fill the water over here, and for sure, some water will gonna come at that side, and it's gonna fill over here, and it's gonna fill over here, 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 right? And I wanted from you to know, after some time, what you will see or what you will recognize is the diagram like देखो कैसा डायग्राम आपको थोड़ी देर बाद दिखेगा. See my diagram very carefully. What I wanted to show you. You will see that कुछ लेवल जो है इन लोगों का सेम आ गया है. Then it came at rest. कि आप जो है किसी भी टाइप का flow of water is not gonna see, right? कुछ भी हमें glance नहीं हो रहा है after that. Right? What you would say कि दोनों में बराबर पानी आ गया है मैम. Then जो है जो water का flow है वो रुक गया है. क्या आप ये कहेंगे? For sure अगर आप ये कहते हैं तो you would think it कि क्या mistake है आपकी. Well, you can clearly see कि we will not say कि दोनों में बराबर पानी आ गया है. Then I would say the flow of water had been stopped, right? No. What you would say? दोनों में बराबर, what I wanted to say, बराबर level का water आ गया, right? I use the word दोनों में बराबर level का water आ गया. That is why that particular water had came to rest on both of the particle, or I would say the glasses. और हम लोग कहेंगे कि दोनों में वाटर सेम आ गया. नहीं, हम लोग कहेंगे दोनों का वाटर का लेवल जो है वो सेम हो गया है. ठीक है. तो सिमिलर गोज विद द पार्टिकल वी वर टॉकिंग अबाउट. ये क्यू बाई टू, यू के क्यू बाई टू. यू जस्ट से मी कि चार्जेस दोनों में बराबर हो जाएंगे. एवरीबडी, यू जस्ट से मी कि चार्जेस दोनों में बराबर हो जाएंगे. नो. एंड आई वुड से रिफ्लेक्ट. ओके. I just said to you that that particular thing is not right. That's wrong. Charge जब तक बराबर होगा तब की बात नहीं है everybody. What happened it? जब दोनों में potential पोटेंशियल जब तक दोनों में, which is denoted by your V, दोनों में जब तक पोटेंशियल, दोनों बॉडीज में जब तक पोटेंशियल सेम नहीं हो जाता, तब तक फ्लो ऑफ चार्जेस विल नॉट स्टॉप और कम टू रेस्ट, राइट? दोनों में चार्ज बराबर हो जाएगा? नहीं, दोनों में पोटेंशियल जब तक बराबर नहीं हो जाएगा तब तक दोनों के दोनों चार्जेस विल नॉट कम टू एट रेस्ट. क्लियर इट आउट एवरीबॉडी? समझ में आया एवरीवन? आई होप सो यू गेट कि क्या क्या small kind of, I would say, mistakes you often can do during the preparation of this particular chapter. So I hope so I was able to help you for that. So, and if you are new to my YouTube channel, do subscribe it and share the video to your friend, and also watch further videos, as I also teach 11th chemistry, physics, as well as your math. And yes, I'll be having the lecture number 2 on the same chapter, having the startup with your Coulomb's law, which for you are super excited. And again, I wanted from you to tell me that you want the first chapter from your math of your determinant or your, I would say, relation and function. Whatever the chapter or whatever the demand is yours, I will work upon that. Thank you for watching and stay tuned and have a great day.